Section 9.4, Arithmetic Series. The objective of this section, to define arithmetic series and find their sums. Lesson vocabulary: series, finite series, infinite series, arithmetic series, limits. An essential understanding: when you know two terms and the number of terms in a finite arithmetic sequence, you can find the sum of the terms. Consider this solve it problem. The first 4 rows of chairs are set up for a meeting. The seating pattern is to continue through 20 rows. How many chairs will there be in all 20 rows? Explain your reasoning. Now, the first thing to do is to notice the pattern. Looks like the first row contains 4 seats, the row behind that, the second row, 5, and then 6, and then 7, and we will have 20 rows of seats. So consider this. Row 1 we know has 4 seats, row 2 has 5 seats. So we notice if we wanted to think of it as the index value, the row number is the index value. Row 1 has 4 seats, row 2 has 5 seats, etc. We're just adding 3 to the index value, or the row number. And so we're going to have this series of numbers, or sequence, 4, 5, 6, 7, 8, all the way up through 20 plus 3, so through 23. And sure, you could add 4 plus 5 plus 6 plus 7 plus 8 all the way through 23, and that would get you through this problem. Even on your calculator, it may not even take that long. But let's look for a simpler technique we can use to find the sum, or the total number of chairs that would be available in this meeting. So consider, well, I see I need to make one quick change to make this more obvious. Alright, you probably see what I did there. I just added our second to last, or our 19th row's number of chairs. I think you'll see why in just a second. Consider what happens when we take our row 1 and our row 20, and we add up the number of seats between those two rows. So 23 plus 4. And notice also what happens when we take row 2 and row 19 and add those together. 22 plus 5, 27 again. What do you think happens when we add row 3 and row 18, which isn't shown here, but we know that would be 21. 21 plus 6, 27. So there's something very fundamental going on here in this arithmetic series. 27 plus 27 plus 27. But how many of those 27s would we be adding together to find the total number of seats? Well, there are 20 rows total, and we're pairing them up. There will be 10 pairs total. 10 times 27, 270. And then to explain your reasoning, you should explain what it is we did here in words. We considered the total number of chairs in each row. We paired up rows in a special way, greatest and least, second greatest and second least, and so on, finding 27 to be the sum of each of those pairs. There were 10 pairs, and 27 times 10 is 270. Just as you found formulas for terms of sequences, you can find formulas for the sums of the terms of the sequences. And remember, that's all a series is. Here's a definition. A series is the sum of the terms of a sequence. A finite series, like a finite sequence, has a first term and a last term, while an infinite series continues without end, or we might say it continues indefinitely. Here are some examples. A finite sequence, 6, 9, 12, 15, 18. A finite series, 6 plus 9 plus 12 plus 15 plus 18. An infinite sequence, 3, 7, 11, 15, etc. An infinite series, 3 plus 7 plus 11 plus 15, etc. An arithmetic series is a series whose terms form an arithmetic sequence. When a series has a finite number of terms, you can use a formula involving the first term and the last term to evaluate the sum. And here's a take note box. You really should take or add this to your notes. Sum of a finite arithmetic series. The sum, S sub n, of a finite arithmetic series, a sub 1 plus a sub 2, and so on, all the way through a sub n, is S sub n equals n over 2 times the quantity a sub 1 plus a sub n. And here's a lot of an explanation of why it works. Feel free to check this out if you're inclined, but I think as we begin using this formula, you'll become very comfortable with it, and also using it to find the sums of arithmetic series.